You can quickly learn how to use RCPA3 functions for political analysis, or really any R functions for analysis, if you know how to use the documentation files that go along with functions. Let me try to break it down for you. We use some different conventions and color in our tutorial videos, but the tutorial videos as well as the documentations are going to show you stuff like this. Starts with a usage statement. A usage statement is like the full specification of the function along with its arguments. The function name appears in the usage statement, and as you can see, this fictitious example, analyze data, it's really two words, analyze data, but a function name can only be one word. And so to mash two words together into one word for programming purposes in R, one convention is to capitalize the name of successive words. So you'll notice there that it's analyzed with capital D data. I point that out because function names in R are case sensitive. Arguments are case sensitive as well. So you want to be aware of capitalization and how it's used. And so like in the preceding slide, I went through the functions in the RCPA3 package and I pointed out that almost all of them end with capital C, and except for the ones that start with capital CI. So when you're using those functions, you want to be aware that it's lowercase, but then it's a capital C at the end. The usage statement, in addition to the function name, will specify the function's arguments, and those are the words that appear in parentheses following the function name separated by commas. In this example, analyze data has arguments named dv, iv, w, data, z, digits, printc, plot, main, xlab, and ylab. Those are the function's arguments, and arguments are like settings to a function. They control what the function operates on and the settings for how the function operates that will affect what it returns to you as results. The function usage statement shows any assignments that are made by default. The assignment operator is an equal sign, so you can see that digits is set equal to 3 by the usage statement having the keyword digits, then the equal sign to assign the value of digits to the value of 3. That's the equal sign is the assignment operator that's used within functions. The usage statement also shows default values. Default values are the values of arguments if none are specified by the user. It defaults to these settings. So for analyze data, for example, the digits will default to the value of 3 if no other value is specified. Print C will be false by default. The capital F stands for false by default, but the user could change it to true. But it's false to begin with unless changed. On the other hand, plot is set equal to the default value of true. Capital T stands for true, so it will produce a plot by default unless the user changes plot equal to false to suppress the plot. I like to break down arguments into a few categories. The user inputs. The usage statement doesn't actually show any user inputs. Those would be values supplied by the user. In the slide, I put user inputs in quotes because most user inputs to assign values to the function arguments, when the user assigns values, they'll typically be in quotation marks unless the assigned value is a number, in which case it doesn't need to be in quotation marks, or it's an object. In the usage statement, capital F and capital T, you can spell it out all caps false, all caps true. False and true are defined objects in the R environment, so we don't need to put those in quotes. We can refer to them by their object names, false and true. Now I wanted to say that it helps to break down arguments into different types of arguments. One type of arguments are the required arguments. The required arguments are arguments for the values must be set by the user for the function to operate. For analyze data, this function, we can read, has two required arguments, dv and iv. That means the user must supply the values, assign the values of dv and iv in order for the analyzed data to argument. In other words, analyzed data won't analyze data unless you tell it what variables that it's going to analyze. There are a set of optional arguments, w, data, z, digits, and print c. In this example, these can be specified by the user, but don't have to be specified by the user. Oftentimes, optional arguments will have default values, but if the usage statement doesn't contain default values, like w and data don't have default values, that means the function can proceed without any default value or user supplied value. They could do analyze data without observation weights, and it can analyze data without the data set name being specified or without there being a control variable. Plot related arguments relate to plots generated by an R function, whether you want to plot, and then some settings for the plot, like the main label, the x-axis and y-axis labels. It's also helpful in a usage statement or a tutorial or a documentation to show that what the results or the output of the function is. So in this case, the analyze data function, it says, produces a table of results and a plot. The output isn't controlled by the user, not directly anyway. It comes from the function itself. So the arguments are set by the user, and those become the inputs to the function. The function does a set of predefined operations, and then the result of those operations is the output to the console and to the plot window. Let's work with a usage statement and some standard arguments of RCPA3 functions to generate some output and do some analysis in the R environment. So this is the freqC function. So its name is freqC. So to use the function, I type in its name and then followed by a set of parentheses, and in parentheses go the arguments. This function has one required argument, x. Actually, you don't have to set x equals whatever I put in the first position inside the parentheses will be assumed to be the first argument, which is x, but it doesn't really hurt to have the x in there for the x argument, and I think in some ways makes the output a little easier to understand. So I'm going to set x equal to a variable, and some of the variables, some of the data sets are already incorporated into the package. So there is an existing data set named NES. So that's an existing object, so I can refer to an existing object by the object name, such as NES, and then select any of the variables within that data set. And there are quite a few of them, and we'll analyze quite a few on our journey of political analysis. Let's just start with the first one to keep things simple, to do a frequency analysis of the NES abortion.imp for the importance assigned to the issue of abortion. When I run this, it is creating a table as well as a figure. So you can see the table here for the frequency distribution of the importance of abortion issue to the respondents of our table, and then a bar chart as well. Now, if you notice in the table, for the calculated values of percent and cumulative percents, there are 2 digits reported after the decimal place. And you can see why if you look at the usage statement. The usage statement says digits equal 2. The assigned value by default of digits is set equal to 2. If I'm happy with 2, I can leave that as is, but if I want to change it, for example, to set digits equal to 1, I add a comma, then the optional argument's digits, and I assign it the value of 1. If I run that, I'll get my table again, and it's rounded off the values, and I get it with 1 digit reported after the decimal point as opposed to 2. Now, let's say I am looking at this plot and I say to myself, I would like to change this automatically generated main title to something that is shorter and maybe easier to understand. To do that, I would select the main argument, and I will set that equal to a user defined value. So do that, I add a comma, then use the main argument, the main keyword for the main argument, and I use the equal sign uh, to assign a value to the argument main. And now I'm going to use a set of double parentheses, and I will, inside the parentheses, write my new title for the plot. Maybe something like Importance of Abortion Issue. I'll give this a run. Let's see how our plot looks. Now, a couple things I want to point out to you. Everything that you include in the parenthesis, inside the parentheses, is kind of treated like it's one line. So for space purposes and to make it easier to read, I like to um, start arguments on a new line if the argument starts getting a little too long. Like here, when I've added the main, I can't see the end of the main equals, so I might start that in a new line, and it will run this and consider this all one argument because the arguments are inside a set of parentheses. Now also notice that when I set x equal to the variable inside the NES data set, I don't have quotation marks around that. I just type the name of the data set, the $, and then the name of the variable. That's because the NES data set is already an object in the package, and I can refer to the object by the object name. When it comes to numbers, numbers don't need to be in quotation marks because the number is already recognized, kind of like recognition of an object. Similarly, if you ever use true or false, you can use capital T for true or capital F for false. You don't need to put capital T or capital F in quotation marks. Those are already objects in the R environment. False and true are already objects in the R environment, so we can reference those objects by name. Contrast that to the setting the user input for the main title. Now I did put that in quotation marks, this string of text, importance of abortion issue. Now this needs to be in quotation marks because this value isn't an object already. I really don't want to create an object for the title. I just want to assign the title when I'm referencing the main argument. So to do that, I set the main equals, and in quotation marks, the quotation importance of abortion issue, and make sure that there's a closing quotation mark when there's an opening quotation mark. So I've used some of the optional arguments. There are more to use. What's else out there to use? Well, you can look at the usage statement to see what other the argument keywords are that are available to you, and then look at the documentation file or the other resources to see what these functions do. Like for example, in this instance, I can see from looking at the usage statement for freqC that the X argument in dark black is required, and then the other arguments are a lighter color, which means that they're optional. Also, the documentation tells me they're optional. So I've modified the digits and assigned it to 1 instead of 2. And I've also used the main argument to create a different main title for the plot, but you can see that there are others there and documentation for those other arguments that we might use or adjust depending on the research situation.